All right, we're looking at solving equations with variables on both sides. So remember, the goal for solving any equation is to isolate the variable. That's the goal, always. You have to get my variable by itself. Okay, so let's take a look at the first one. 8x minus 16 equals 4x plus 20. If I have variables on both sides, I need to move them to one side. Doesn't matter if it's on the left or the right. I usually like to have my variable term on the left. So what I'm going to do is to get rid of this positive 4x, I'm going to subtract 4x from both sides of my equation. That will cancel it here and make the 8x a 4x because 8x minus 4x is 4x. Bring down the rest of the equation. So now I have a nice, easy two-step equation. I would add 16 to both sides. It's going to give me 4x equals 36. Ooh, divide by 4, I get a whole number here. This is exciting. Whenever I make up an equation and I get a whole number, it makes me very happy. Divide by 4 and you'll get x equals 9. And again, don't forget, you can always plug this variable in to the equation and see if you do get a true statement, see if it is actually correct. Next one, number 2, I see parentheses here. So before I do any moving things around, I do need to make sure that both sides of my equation are simplified as much as possible. So that's going to leave me with negative 12m plus 4 equals 20m plus 36. Don't forget, a negative distributed into subtraction will end up being a positive 4. Just do the same thing as last time. I'm going to move the 20m. I'm going to get rid of the 20m on the right and move it over to the left. It's going to cancel it here and make my m term negative 32m plus 4 equals, bring down that 36. Okay, from here, I got a nice, simple, standard two-step equation. I'm going to subtract 4 from both sides. It's going to give me negative 32m equals 32. No way. Did I get a whole number again? Oh my gosh. Divide by negative 32. Man, this is a good day. M equals negative 1. That never happens. 2 in a row whole numbers. I'm on fire. All right. Number 3. C parentheses. Right off the bat, distribute. The left-hand side of my equation will become 10m minus 5, and then bring down the rest equals 10m minus 5. Now, you should have some sort of trigger go off in your head that makes you think, something's interesting about this equation. 10m minus 5 equals 10m minus 5. That's an interesting equation here. Let's go about things as usual and see what's going to happen here. So I'm going to move my m term by subtracting it. Do the same thing to the other side of the equation. But if you look here, both of my m terms are going to cancel out, and I'm left with negative 5 equals negative 5. Once I get to that point, that's when I realize here that if I have a value for m and I plug it in, aren't I always going to get a solution? If I do 10 times 2 on the left, minus 5, and then 10 times 2 on minus 5 on the right, I'm going to get the same answer. Whatever I plug in for m, I'm going to get the same value on both sides of my equation. So if my variable terms cancel out and I'm left with the same constant, that means that there are infinite solutions to this equation. Okay, let's take a look at the next one, number 4. 14y minus 6, I need to distribute. I see parentheses. That's going to give me 14y plus 20. Okay, and again, you might notice something here right off the bat. Be like, wait, this seems weird. Let's go about business as usual. Subtract 14y, and I will get both of my variable terms canceling out, which will leave me with negative 6 equals 20. That is by no means true. That is not true. Negative 6 is not equal to 20. So in this case, if my variable terms cancel out and I'm left with two constants that are not the same, there are no solutions to this equation. Okay, there is not a solution that exists to this equation.